Okay, in my previous lectures, we went through the first 5 definitions in Book 1 of Newton's Principia. We should tidy up our discussion before moving on to Chapter 20 by talking about his last 3 definitions, definitions 6, 7, and 8. And I have to admit that the first time I read this, I was a little bit perplexed at what he was getting at. But I think this is, if you understand what he's getting at in these last 3 definitions, it will help us to understand some of the things he does later on. So let's look at definition 6, first of all, and then definition 7, and definition 8. And what you have to realize in each of these definitions, he's really teasing out some of the aspects of centripetal force. So these all 3 have to do with this concept of centripetal force, which he had just defined in the previous definition, definition 5. You'll remember a centripetal force is a force that acts on a body so as to direct it toward a point as toward a center. So for example, a string pulling on something as you're swinging it around, or I use an example of a hockey stick hitting a puck that it's sliding by toward a certain point. Okay, so let me just mention what these 3 definitions are. He talks about the absolute quantity of centripetal force. He talks about the accelerative quantity of centripetal force. And he talks about the motive quantity of centripetal force. And whenever he talks about quantities, it's important to, that's kind of a clue that he's going to be talking about how we measure something. Okay, so what is the absolute quantity of centripetal force? The way he explains this is how the absolute quantity of centripetal force is how strong the force is. So this is a measure of how strong the force is. That's what we call the absolute quantity of centripetal force. So for example, the example he gives is if you have a big magnet, it can produce a stronger absolute quantity of centripetal force than a small magnet. So a big magnet, which is acting on another magnet, let's say, can produce a large absolute quantity of centripetal force. So whenever he uses this term, the absolute quantity of centripetal force, he's talking about how strong that force is. Now, what about the accelerative quantity of centripetal force? Oh, by the way, I'm going to write this right here. This is F sub c. The size of this number tells us what the absolute quantity of centripetal force is. The accelerative quantity of centripetal force, I'm going to suggestively write AC, because what he's talking about here is nowadays what we would call the centripetal acceleration. He calls it the accelerative quantity of centripetal force. So we would call this a centripetal acceleration. It is the way an object responds to a centripetal force. And the bigger the centripetal force, the bigger the absolute quantity of the centripetal force is, the more this object is going to accelerate. So when he talks about the accelerative quantity of centripetal force, he's talking about the response that an object feels to the absolute quantity of centripetal force. And we would call that centripetal acceleration. We might also talk about it as the rate at which the object's or a body's velocity is changing due to a centripetal force acting on it. So if this is sort of the cause, this would be the effect, and this is A sub c is kind of the measurement of the effect of that cause. Okay, and now finally, what about the motive quantity of centripetal force? He explains this as basically the same thing as the accelerative quantity, but multiplied by the quantity of matter, or what we would say the mass. So we would call this the mass times the centripetal acceleration. Okay, it's found by multiplying, so it's obtained by multiplying the object's or the body's mass by the accelerative quantity of centripetal force, or the centripetal acceleration. Okay, so remember, what he's trying to do here is he's just trying to develop a language for how he's going to be talking about causes and effects. And he needs to define some terms so that later on when he's talking about it, we're all clear on what these definitions mean. So these are the 8 definitions that Newton provides at the outset of book 1. And why don't we stop there?